In Lesson 2.5, we're going to learn how to use linear models. We're going to write linear equations using real-world data and our graphing calculator, and we're going to be able to make predictions from those linear models. So let's first of all look at some definitions and terminology. The first thing we will talk about is what is a scatter plot, and this should be something you've actually done before. A scatter plot is a graph that relates two sets of data by just plotting the data as ordered pairs. So if you'll notice here, I have an example of a scatter plot. You have some temperatures in degrees Celsius and some dollar amounts on the y-axis, and we've just randomly selected data and plotted the points. When you have points plotted on a scatter plot, one of the things you're going to want to do is to look to see if you have a correlation between your data. And that's nothing more than just a relationship between the data. We want it to have a strong relationship, and we characterize those by whether we have a positive correlation, a negative correlation, or sometimes there would be things that have no correlation at all. So if you look, I have some examples of both positive and negative and no correlation. In our first example, we have a high positive correlation between our x and a y because the more that the dots lie in a straight line, then the stronger the correlation is going to be. So notice that these dots do kind of follow along a line or a linear pattern, and so we'd expect them to have a strong correlation. In the next example, we have a low positive correlation. The data appears to be kind of falling in a line, but it is kind of scattered out quite a bit, but it still has a pattern that looks like it's following a line. In our third example, we have something that would have no correlation at all. An example of that might be something like if we had our height and our GPA. We would not expect those to have any kind of relationship, and so you'll notice that our dots are just scattered everywhere. In our next picture, we have a low negative correlation. Notice that in that case, our dots are decreasing as our x's are getting bigger, our y's are getting smaller. And again, even though this appears to be following something that looks linear, it's not. The dots are scattered out quite a bit. And then our last example, we have a high negative correlation, and you can see that those dots follow along a linear pattern, and they're pretty close to being in a straight line. Now let's go back to our first scatter plot and talk about what we call a trend line. A trend line is a line that's going to approximate the relationship between the variables of a scatter plot, and we can use those trend lines to then make predictions about our data. So if I were to look at this data, I want to try to find a line that would model as close to those dots as I could. So I might expect a trend line to maybe look something like this. Now, the trend line that gives us the most accurate model is called our line of best fit, or our regression line. And one of the things that we'll do in this lesson or in this section is we will use our graphing calculator to compute the line of best fit. Each line of best fit has what we call a correlation coefficient, which we symbolize as an R, and that always is some number between 1 and -1. The closer the value is to either 1 or -1, the stronger the correlation or the relationship, and the more accurate your predictions are going to be. Here are a few pictures of what our data might look like for various values of R. So let's say we have an R value that's -1. Notice that our data falls perfectly in a straight line with a negative slope. If you have an R of -0.7, then that would be something that would resemble this. Notice that you kind of can see a linear pattern, but you do have a lot of dispersion in your dots. An R of -0.4, notice how scattered out the dots are. If your R value of 0, then there's no linear correlation at all, and notice the dots are just everywhere. An R of 0.3, you might see that they're starting to take shape as a positive line. An R of 0.8, notice that most of the data does fall along a line. You have a few what we might call outliers. And then if R is 1, you would have exactly a perfect line that would have a positive slope.